Very good. Another example for you. Suppose I ask you to solve the following equation. Number 2. It says e to power negative x squared is equal to e to power negative 3x minus 4. Well, here we have the same basis for this exponential function to the left, to the right. Since the base for both sides is e, it means that we can set the exponents equal. So what's the first exponent? What is the second exponent? The first exponent is negative x squared, and the second exponent is negative 3x minus 4. So negative x squared is negative 3x plus 4. Add x squared to both sides. So x squared minus 3x plus 4 is 0. How do we solve this? We can write this in factor form. We're looking for two numbers. Their multiplication is positive 4 and their sum is equal to negative 3. Can we find those numbers? Multiplication is 4. Oh, this is negative 4. And their sum is negative 3. Negative 4 and positive 1 are the numbers that we are looking for. Very good. Thank you, Justin. So x is negative 1 and x is 4. We found two solutions for this equation. Very good. Now suppose I give you this equation. I say, hey guys, solve number 3, log of a negative x squared equals to log of negative 3x minus 4. Again, when the basis is not given, the basis is just 10. So what are you going to do? You're going to say that, hey, since I have the same basis, 10, I can take these quantities and set them equal to each other. Very good. Negative x squared is negative 3x minus 4. So we're going to add x squared to both sides. So you get x squared minus 3x minus 4 equal to 0. The same process. X minus 4 times x plus 1 is 0. So x is 4 and x is negative 1. Very good. So which one is acceptable? When it comes to log, we should be careful. You have a log of negative x squared and you have log of negative 3x minus 4. Why is that? Remember, the log is the inverse of exponential function. If you have y equals to b to the x, its inverse, let's write it as f, so you don't confuse it, but 1 over y. So if f of x is b to the x, inverse of f is a log with base b of x. Remember that when you're graphing a function and its inverse, suppose b is larger than 1, this is b to the x, their graphs are mirror image of each other with respect to the line y equals to x. So the inverse of b to the x, which is your logarithmic function, is here, log with base b of x. What's the domain of a log with base b of x? X is only positive value. So for the log b of x has a positive domain. Positive domain. What do I mean by that? It means that this quantity, whatever is here, well, no matter it is x or it's a quantity, you have to have it larger than 0. Now take a look at this equation. On the left-hand side, you have negative x squared. Let us take a look at Desmos. Let's get help from Desmos to graph log negative x squared. So let me open up Desmos. Let's take a look at Desmos together. So here we have log of negative x squared. There we go. So what do we see here? Do we see any graph? If I just ignore this negative, take a look at the graph. This is the graph of log x squared. But if I plug in negative, what happens? It says, hey, you do not have any graph for log of negative x squared. Why is that? What's the reason behind it? Suppose I plug in 1 for this function. What is log of negative 1? Log of negative 1. Okay, let me use my calculator. What is, let me find log of negative 1? Error. Guys, the log of negative number is not defined. Take a look at this. Again, look at your graph. If I just graph log of x squared, hey, I have a graph here. That makes sense. If I plug in any number, it gives me some values back. But if I put a negative sign in front of x squared is always positive. Negative, positive is always negative. Take a look at this. If I plug in log of negative 1, I get an error. If I plug in log of negative 2, another error, and so on. That's why you do not see any graph for log of negative x squared. What if I want to graph log of, for example, minus x? Hey, guys, I just flip log of x. This is log of x, and this is log of minus x. We get, well, as you can see, here you have reflection with respect to y-axis because we're changing our x values. Am I right? So as you can see, the log is not defined on the left-hand side. If you plug in any negative number, we get an error. Let's go over another example. Example number 4. Question says, well, now solve this guy for me. E to the x is equal to 55. Okay, e to the x is equal to 55. What should I do here? I'm going to use the properties for exponential function and its inverse to solve for this exponent x. But how? Here, you can take the ln of both sides. Take the ln is log with base e of both sides. Okay, this is new. It's not actually very new. We saw these properties before. Ln of left-hand side is equal to ln of right-hand side. Ln of e to the x is ln of 55. Well, remember the properties of ln. If we have ln or log of, let me write down as log, if we have log of a quantity to some exponents. So suppose it has an exponent. This quantity has an exponent like alpha. I can take this alpha and write it in front of the log. This alpha as the exponent becomes the coefficient. Alpha times log of this quantity, whatever it is, with basis b. This exponent is your alpha here. We're going to take this exponent and write it in front of ln. X times ln of e, the pure number, is equal to ln of 55. On the right hand side, guys, we have to use our calculator. ln of 55. Well, what is ln of e? ln of e, or log with base e of e, is always 1. So we get x times 1 equals to ln of 55. On the left hand side, we have x. On the right hand side, we have ln of 55. We can use our calculator to approximate ln of 55, which is 4.007. Calculator. So we learned something new. ln of e, or log with base e of e, is always 1. We have a rule. This rule says log of any basis of the same quantity is always 1. So if basis and the quantity are the same, the log becomes 1. So if the base and the quantity are the same, then the log is 1. This is the law that we have. Here we have ln of e. ln is log with base of e. Quantity and the base are the same, so log becomes 1. That's how we use it here. ln of e is just 1. X times 1 is x. On the right hand side, we have ln of 55, which is approximately 4.007.